Namaskar. In this video, we are going to discuss few important named reactions given in alkyl and aryl halides unit. What are named reactions? Named reactions are the reactions which are given the names of the scientists who designed and developed them. The first reaction we are going to see is Wood's reaction. It is a coupling reaction by nature. Here, two alkyl halides react with sodium metal in dry ethyl ether medium to give alkanes. So, the alkyl units combine, two such alkyl units combine to give alkanes. If I take methyl chloride, two methyl groups combine to give ethane. If I take ethyl chloride, two ethyl units combine to give N-butane. Instead of taking one alkyl halide, if I choose two alkyl halides, I would get a mixture of products as listed here. See, when we take methyl chloride and ethyl chloride, when two methyl chlorides combine, ethane is produced. When two ethyl units combine, N-butane is produced. When methyl and ethyl groups combine, that produces N-propane. So, such a mixture of product is obtained, and this leads to the production of unsymmetrical alkanes as well. So, by using Wood's reaction, we can produce symmetrical alkanes as well as unsymmetrical alkanes. The reaction we are going to discuss is Finkelstein reaction. It is a nucleophilic substitution reaction by nature. In this reaction, alkyl chloride or alkyl bromide is converted to alkyl iodide. For this transformation, we use sodium iodide in acetone medium. This reaction can be done for any alkyl chloride or alkyl bromide, and we get sodium chloride or sodium bromide as a byproduct. We have the next reaction, Schwarz reaction. It's much similar to the earlier reaction. Here the alkyl bromide and alkyl chloride is converted to alkyl fluoride. Recall the earlier case. Here it was alkyl iodide at the end. Here it will be alkyl fluoride. So, from alkyl chloride and alkyl bromide, we get alkyl fluorides. For the transformation, we use any one of these fluorinating agents. This is silver fluoride, mercurous fluoride and antimony trifluoride. Any one of them is used. Moving on to the next reaction, Fittig reaction. It's very similar to Wood's reaction. It is again a coupling reaction as Wood's reaction. In the case of Fittig reaction, we take aryl halide instead of the alkyl halide we took in Wood's reaction. That's the only difference. The other things are the same. So, two aryl units combine to give bi-aryl as the final product, that is Fittig reaction. In case if I take bromobenzene, I would get dibenzene. If I take chlorobenzene, I get dibenzene. The next reaction is Wood's Fittig reaction. It's a combination of the reactions we mentioned earlier, that is Wood's reaction and Fittig reaction. It is again a coupling reaction. We take one alkyl halide and one aryl halide, and the other reaction conditions remain the same as in the case of the previous two cases, that is Wood's reaction and Fittig reaction. So, one aryl halide and one alkyl halide in presence of sodium and dry ethyl ether. We get aryl benzene as the product. Example, bromobenzene and methyl bromide, we get toluene as the final product. So, this is a combination of the earlier two reactions. The next reaction we are going to discuss is Sandmeyer reaction. It's a substitution reaction by nature. In this reaction, we are going to take aryl diazonium salt. This salt is a very stable salt produced from aryl amines using diazotization reaction, and this diazonium salt reacts with cuprous chloride, cuprous bromide or cuprous cyanide, any one of them. Based on the salt we take, the final product varies. In case if I take cuprous chloride, I would get chlorobenzene. If I take cuprous bromide, I would get bromobenzene. This particular unit will go away as nitrogen gas. The next reaction is Gattermann reaction. Here the reactant and the final product is the same as in the case of Sandmeyer reaction. The difference lies in the reagent. In the case of Sandmeyer reaction, it was cuprous salt. In the case of Gattermann reaction, it is hydrogen chloride or hydrogen bromide in presence of copper powder. The reagent is different here. Instead of taking cuprous chloride or cuprous bromide, here hydrogen chloride or hydrogen bromide is taken in presence of copper powder. That's the only difference. Both the initial reactant and the final product resembles the earlier Sandmeyer reaction. Here also this particular unit goes away as nitrogen. Moving on to the next reaction, Balz-Schiemann reaction. It is pronounced as Schiemann. This is a type of substitution reaction. In this case again we start with aryl diazonium salt. Here we allow it to react with hydrofluoroboric acid. This is hydrofluoroboric acid. This particular chloride is replaced by fluoroborate ion, and this is a stable solid. This stable solid on heating, this is one step. So in the second step we heat it. On heating, this escapes as nitrogen, and from this fluoroborate ion unit BF3 is removed. Finally aryl fluoride is produced as one of the products. So the main product is aryl fluoride, and this reaction takes place in two steps. The next reaction we are going to see is dose process. It's a nucleophilic substitution reaction by nature. In this case, chlorobenzene reacts with sodium hydroxide. It's an aqueous solution. This reacts at a very high temperature and very high pressure. So the temperature is around 623 Kelvin and the pressure is maintained at 300 atmosphere. The atmospheric pressure we already know is 1 atmosphere. For this reaction, such a high pressure is needed. So the first step, the chlorobenzene is converted to sodium phenoxide. In the second step, this phenoxide is neutralized or acidified with hydrogen chloride to get phenol. It is not only a laboratory process, it's an industrial process for the manufacturing of phenol. It's a very important commercial process. The next reaction we are going to see is Riemann-Tiemann reaction. It's an electrophilic substitution reaction. In this case, phenol reacts with chloroform and aqueous sodium hydroxide, and aldehyde group is introduced in the benzene ring. This is an ortho substituted product, ortho-hydroxybenzaldehyde or salicylaldehyde. In addition to this, we will be getting a para isomer as well. So para product also is got. Para product also will be got, and this will be a minor product.